Welcome to the third video of the series. This video will cover the concepts of scope chain, pass by value and pass by reference. We start by understanding the concept of scope chain, and I assume that you are aware of different type of scopes in JavaScript. If you wish to learn more about the different type of scopes, I suggest you to watch the second video of this series titled Function Scope and Function Expression. We start with a quick recall of different type of scopes. I'm sharing an image of a code snippet I've started debugging. The left part of the image highlights the local and the global scope, and the right part of the image is the code I'm debugging, and the breakpoint is set at the first statement. Now, the global scope is an environment that is provided to execute the script, and the local scope is when we execute a script, all the functions defined in the script and any variables defined outside any function or block are part of the local scope. So once the script finishes the execution, all these variables and functions are out of scope as well. So in this example, the function test scope and the variables x1, x2 and x3 are part of the local scope. In the second image, the breakpoint is on the first line of the function test scope. Now on the left, we now have a function level scope where the variables defined in the function are available. Now it has another block, closure, which shows the variables declared outside the function scope, which are accessible within the function. And once the execution of this function is complete, the variables will also go out of scope. Just to share one more thing, the closure is visible to us because we have the console.log statement in our function. If we comment those two statements, we will not see the closure block. Finally, the block scope. In the third image, the breakpoint is at the first line of the block. Since we have defined the block within the function, the block scope is visible under the function test scope. Now in this example, the variables under the block scope are z1 and z2. These different scopes in JavaScript help improve code's readability and maintainability. The code becomes easier to understand with clearly defined boundaries and less likely to cause unexpected behavior. It also prevents naming conflicts caused by accidental overwrite of variables with the same name, as the variables are compartmentalized. Now these are possible only when we follow the prescribed guidelines of declaring variables using keywords like let and const, limit the use of keywords like where, and avoid declaring a variable with no keyword. Now we'll learn about scope chain. Now as the name suggests, the scope chain concept connects these different scopes and describes how a variable is accessible within the code. You can think of these different scopes as a linked list with each scope pointing to its enclosing scope. So when a variable is looked up, JavaScript looks for it in the current scope, and if the variable is found, the lookup stops. Otherwise, the search continues to the enclosing scope until the outermost scope is searched. Now JavaScript throws an error if the variable is not found in the scope. Now in our example, the first variable x4 of the first console.log statement, the search starts from the block scope. This goes up to the function scope, then the local scope, and finally the global scope where the variable is found and displayed. Understanding the concept of passing an argument to a function as a value or reference is very important. So with a good understanding of this, we can learn to handle variables and data correctly. This is very important for writing predictable and efficient code. We start with pass by value, and for this we must understand the concept of execution context. Now when JavaScript starts executing a script, it creates an execution context for the script. This is the global level execution context, and it has two phases. The first phase is the creation phase, where the script is read and all the functions and variables which are declared outside the function or block context are declared. It defines the global and the local script level scope, which we noticed while we were doing the quick recall of the scope. Second is the execution phase. JavaScript execute the code in this step, and it is where the values of variables are assigned as the code executes. JavaScript maintains this context in a call stack. starting with the storing of the global execution context. And JavaScript uses this stack data structure to keep the track of all the execution contexts. These contexts are managed in a last in first out manner, and each entry in the call stack is called a stack frame. When JavaScript executes a function, it creates a function level execution context. Now this context contains the parameters passed to a function and the variables defined in the function. Well, there are other things also which we are not discussing at this point in time. Whenever a new function context is created, it is also created on a call stack, and JavaScript for all the function parameters of primitive data types like boolean, number, null, undefined, etc. creates a copy of these on the stack frame. Any change made to the parameter values are not reflected outside the function. Now the question is, why does JavaScript creates a copy of the primitive data type on the stack frame? Well, the first reason is that the primitive data types are immutable. This means that a value of a variable cannot change once it is assigned. And if we change the value, a new modified value is created instead of updating the existing value. To ensure this immutability, JavaScript creates a copy of primitive data types on the stack frame. Another reason is that the variables of the primitive data types point to the actual values. Now these variables have small and fixed size, and copying them on a stack frame is a very straightforward process. Since stack memory is faster as compared to the heap memory, this makes the code execution faster. Now it's time to understand pass by reference. And for this, we start by understanding the concept of a user-defined object. Generally, a developer or a programmer defines a user-defined object, and it is a complex data type that stores data as a key value pair, and these key value pairs are referred to as properties. But why do we need these objects? So when we write a software to solve a real life problem, we use these objects to represent an entity. For example, we define an entity called car, and this car has different properties like its make, model, color, year, etc. We use these primitive data types to represent the values of these properties, and these collectively represent one complex user-defined object. In this example, make, model, color, and year are the keys, and we use a key to access its corresponding value. Now these keys are unique, which means an object cannot have two keys with the same name. The value can be any valid primitive JavaScript data type, and in this example we have 3 string values and 1 number value. A value can also be an object or a method, but we are not going to cover these two at this point in time. Now we will see how JavaScript manages these objects. So when it comes to user-defined objects, JavaScript, unlike primitive data types, creates these on the heap. And the variable contains the object reference. So in this example, the variable car will have a reference of memory block where this object is created. And when we pass an object to a function as an argument, we pass an object's reference. And JavaScript, before executing the function, just like any primitive data type, creates a copy of the object's reference on the stack frame. This means two variables, in this example the car and the obj, refer to the same memory block or address on the heap. So when we change an object's property in the function, we change the make of a car from Suzuki to Toyota. This change is also reflected in the original object. The console.log statement after the function call will show an updated car object. In the second code snippet, we again create a user-defined car object and pass this object as a parameter to the function objScope. Now the first statement of the function objScope displays the user-defined object it refers to. In this case, it's the car object. Now the second statement, the parameter object now refers to a newly created user-defined object with only one property. Now it has no reference to the original car object. Any change that we make to the object using the parameter obj will be made to the new object. This is reflected in the following console.log statement as it displays the new object instead of the car object. Once the function execution is complete, the last console.log statement still refers to the car object instead of pointing to a new object that we created in the function. To reiterate, when we change the property of an object in the function, the change is reflected in the original object as well. And when we make a parameter refer to a new object, there is no change to the original object. With this, I wrap up the video and let's summarize what we have learnt in this video. Thank you for watching this video. If this video has helped you, please like it. If you think this can help any of your friends, do share it. And finally, do subscribe so that you don't miss any other videos in future. Thank you very much. Keep learning.